An expected value is an average of the results we would get from an experiment if it were performed an infinite number of times. It tells us what the results would be over the long term. So here's a simple example. Amy's going to flip a coin. If it lands on heads, she'll give Brad $1. If it lands on tails, though, Brad has to give her $1. Does it seem like a fair game? Turns out it is a fair game, and we want to prove that it's fair using the expected value formula. So first, in order to do the formula, we need to know the probabilities of the different outcomes. So her chance of losing this game is 1 in 2. Her chance of a win is also 1 in 2 because it's a fair two-sided coin. Keep in mind that these are theoretical probabilities representing the average of an infinite number of coin tosses. On average, it'll land on tails half the time. So she'll average 0.5 wins per toss. And it'll land on heads half the time, so she'll average 0.5 losses per every toss. Now we want to plug into the expected net gain formula. And there's going to be a probability of her win times the amount she gets if she wins. That's part of it. Then we have to take into account the probability of a loss and the amount she gains if she loses. Now, some expected value calculations require more terms than this, but here there's only 2 possibilities, so we can stop there. E stands for the expected value. So let's plug in the probability of a win. It's 1 in 2. The amount she gets if she wins is $1. But she also has a 1 in 2 chance of losing. And here we have to write in the gain, but it's not a gain, it's a loss. So we want to make that negative, which means money doesn't come into her, she has to pay it out. All right, so what does this represent? On average, 50 cents per play for a win, and she'll lose 50 cents per play on a loss. What does that come out to? 0. And when the expected net gain comes out to 0, then you know it's a fair game. It means you won't end up ahead or behind over the long term. You're expected to break even. So let's look at another application of this formula. But it's important to think about what the meaning of the formula is. It's an average over the long term. But let's say that it's estimated that 17,000 people will attend a festival if it's dry. But if it rains, only 5,000 people are expected to attend. Now let's say there's a 40% chance of rain. Can you find the expected value? So the formula to use here would be the probability of dry times the amount of people who will show up if it's dry, plus the probability that it's raining times the amount of people who show up when it rains. So if it's a 40% chance of rain, then we want to put that here. And that means it's going to be a 60% chance of it being dry. But we got to multiply by the numbers of people that will show up in those different circumstances. So it said that 17,000 people will show up if it's dry, and only 5,000 if it rains. We want to plug that into calculator and get 12,200 people. Now, does that mean that we should expect that 12,200 people will show up at this festival? The answer is not exactly. This is an average over the long term. If an infinite number of festivals were held under these same conditions, where there was a 40% chance of rain, then if we were to add up all the results and find out how many people on average showed up to these festivals, it would be 12,200 people. So it doesn't necessarily tell us how many people are going to show up to the next festival. That could vary quite highly. It tells us the average over the long term.